All right, today we're going to talk about solving quadratics using the quadratic formula. This is something you're going to have to memorize. So the quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. We can break that down a little bit by saying it's the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. And where have you seen that opposite of b over 2a before? Well, if you said it's the axis of symmetry, you're correct. So what we've got is the axis of symmetry in the middle, and then we have values on either side of the axis of symmetry. So that's what the quadratic formula means. So let's take a look at an example. We're going to solve x squared minus 4x minus 7 equals 0. So we're going to break it down. That's a little too thick. We'll put it here, and we'll get rid of that one. Okay, so a equals 1, b equals -4, and c equals -7. So we're going to recall the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you want to write this down each time because you have to memorize it. So it helps if you write it down. All right, so let's fill in what we know. So x equals the opposite of -4 plus or minus the square root of -4 squared minus 4 times 1 times -7, and extend that a little bit, all over 2 times 1. All right, and I'm going to put a big note here. Remember to use parentheses when dealing with negative numbers. All right, because the opposite of -4 does not equal -4. All right, so then we've got x equals 4 plus or minus the square root of 16 minus 20. I did the same thing. Minus -28 all over 2. So x equals 4 plus or minus square root of 44 over 2. Okay, and we're going to break that up. And we've got x equals 4 plus the square root of 44 over 2. And x equals 4 minus the square root of 44 over 2. So that means that our solutions are x is approximately 5.32, or x is approximately -1.32. Okay? And if we check it, excuse me, we can see if we graph it on the graphing calculator, we can see that over here, we've got our axis of symmetry. Remember, this is our axis of symmetry. Plus the square root of b squared minus 4ac over 2a is approximately 5.32. And over here, we've got our AOS minus the square root of b squared minus 4ac over 2a is approximately 1.32. So we've just checked to make sure that we've had it correct. Okay? So here's another example, and we've got 21 minus 4x is equal to x squared. And you got to remember, put this in standard form. Okay? So to do that, I'm going to subtract x squared from both sides of my equation. And I've got negative x squared minus 4x plus 21 equals 0. Now I can determine my a, which is negative 1, b, which is negative 4, and c, which is 21. All right, so we're going to put it into our quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac over 2a. All right, again, write this down. Otherwise, you won't remember it. Okay? So now we're going to fill in what we know. We know that x is equal to the opposite of b, so the opposite of negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 1 times 21. I need to extend my square root sign. And that's 2 times negative 1. So x is equal to 4 plus or minus the square root of 16 plus 84 all over negative 2. So if I simplify that, I get x is equal to 4 plus or minus the square root of 100 over negative 2. All right, so now we can calculate our roots. So x is equal to 4 plus the square root of 100 over negative 2, or x is equal to 4 minus the square root of 100 over negative 2. So here I get x is equal to, negative 7, or x is equal to 3. All right, we can check that on the graphing calculator by putting it in, and we see that we're correct. X is equal to negative 7, and x is equal to 3. So remember, you can always check it on the graphing calculator. All right, so here's one I want you to try. X squared minus 2x is equal to 24. Pause for a minute, and then come back and we'll solve it together. All right, so the first thing that we had to do was we had to put it in standard form, which means we had to subtract 24 from both sides, and we get x squared minus 2x minus 24 equals 0. So now our a is 1, b is negative 2, and c is negative 24. All right, so go back to our quadratic formula. X equals opposite of b plus or minus the square root b squared minus 4ac all over 2a. And what was my mantra before? Write this down. Otherwise, you won't remember it. All right, we're going to substitute now. So x is equal to the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 24, all over 2 times 1. Okay? So, excuse me. That gives us x is equal to 2 plus or minus the square root of 100 over 2. So if I break it up, I get x is equal to 2 plus 10 over 2. So x is equal to 12 over 2, or 6. And I've got x is equal to 2 minus 10 over 2, or x is equal to negative 8 over 2, and x is equal to, I didn't divide. X is equal to negative 4. All right, and again, we're going to check it on the graphing calculator, and we see that x is negative 4 and x is 6 are our two solutions. All right, so now we're going to talk about how we can determine how many solutions we should have. And that's called the discriminant. The discriminant is the expression b squared minus 4ac. And remember, we got that from our quadratic formula, which says x is equal to the opposite of b plus or minus b squared minus 4ac. And there it is right there. That's our discriminant. Okay, it tells you the number of real solutions of the equation. So if b squared minus 4ac is greater than 0, there are two real solutions. If b squared minus 4ac equals 0, there is one real solution. And if b squared minus 4ac is less than 0, there are no real solutions. Okay, and that's important. You may be asked on the EOC, how many solutions does this have? And you may have to determine the discriminant. All right, so here's an example. We're going to find the number of solutions for x squared minus 4x plus 3 equals 0. So here a is 1, b is negative 4, and c is 3. So write b squared minus 4ac. And what should we do? Yes, we should write this down. All right, so we've got b squared, which is negative 4 squared. Notice I put the negative 4 in parentheses, minus 4 times 1 times 3. So it's going to be 16 minus 12, which is 4. Okay, so the discriminant is greater than 0, so there are two real solutions. All right, and we're going to check it by graphing it on the graphing calculator, and we see that there are indeed two real solutions. Okay. Here's another example. We've got find the number of solutions for negative x squared plus 4x minus 4. Here are a is negative 1, b is 4, and c is negative 4. So we've got b squared minus 4ac. And what should we do? Write it down. Okay, so much for the commercial. So we've got 4 squared minus 4 times negative 1 times negative 4. That equals 16 minus 16, which is 0. Okay, so the discriminant is 0. So there is one real root. All right, and we're going to check it. And we check it by graphing it, and we see that it touches the x-axis at only one point. All right. Our next example, we're going to find the number of solutions for x squared minus 4x plus 5 equals 0. Here our a is negative 1, b is negative 4, and c is 5. So we've got b squared minus 4ac. And we are going to do what? Yes, write it down. You won't remember it on the test otherwise. Okay? So we've got negative 4 squared minus 4 times 1 times 5. And that equals 16 minus 20, which is negative 4. Okay? So here, our discriminant is less than 0. So there are no real roots. All right, and we can check it, putting in the graphing calculator, and we see it doesn't touch the x-axis. And if it doesn't touch the x-axis, we see that there are no real roots. Okay, so today we talked about the quadratic formula. And that's equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that helps us to find the solutions. And we also talked about the discriminant. And the discriminant, which is b squared minus 4ac, we said that that was this part under the radical sign. And that tells us the number of solutions we can expect. All right, that's it for today.